Welcome back. Today we are going camping in the random forest of machine learning. Machine learning is one of the most transformative tools in modern policy making. As Varian pointed out, conventional statistical and econometric techniques such as regression often work well, but there are issues unique to big datasets that may require different tools. Why? First, the sheer size of the data involved may require more powerful data manipulation tools. Second, we may have more potential predictors than appropriate for estimation, so we need to do some kind of variable selection. And third, large datasets may allow for more flexible relationships than simple linear model. In these cases, machine learning techniques such as decision trees allow for more effective ways to model complex relationships. Today, we will see an application of machine learning using an example from a research by Battaglini and others, which shows how big data in technology can boost the effectiveness of tax audits. What's the core question? In simple terms, how can machine learning improve the way tax authorities select audits? Now, we all know that tax authorities routinely collect extensive data sets on tax returns and audits. The question here is, can they use this data more efficiently to recover more evaded taxes? This is crucial because traditional auditing often relies on human judgment, which of course can miss high-value cases of tax evasion. A data-driven approach could help authorities recover significant funds, which could be reinvested into public services. So the goal here is to accurately identify those taxpayers who are highly likely to evade taxes and focus audits on them, reducing the need for costly random audits to the general population. Now, to do this, the researchers used machine learning with random forest predictions applied to the Italian case. First of all, what is a random forest? Imagine you want to predict if a taxpayer is likely to evade taxes based on certain factors, like their income or location. A random forest creates many decision trees, even thousands, each tree representing a different way to sort or split the data based on these factors. Now, each decision tree asks a series of false or true questions, yes or no, like, is the taxpayer's income above a certain level? Yes or no. Is the taxpayer business in a specific sector? Yes or no. Each tree makes its own prediction based on these questions. Then the random forest combines the predictions from all these trees to make one final, more accurate prediction. This way, it can catch patterns that a single tree might miss. Now, using this approach, the researchers trained the random forest on data from thousands of tax audits, allowing it to learn which factors are most associated with evasion. How do we know now that the model's predictions are accurate? That's where training and out-of-sample testing come in. First, the model is trained on a large sample of data, and this is the training sample. Here, basically, the model learns patterns by seeing which factors were associated with tax evasion. After training, the model is tested on unused data, and this is called the out-of-sample test. This test checks if the model predictions hold up when it sees fresh data it hasn't encountered before. testing on unused data helps prevent the model from being overly specific to the training data, making it more reliable for future predictions. Now back to Battaglini and co-authors. They trained their model on a large dataset from the Italian Revenue Agency, including all small business tax returns and audits. Now they have, first, the universe of tax returns of sole proprietorship taxpayers in Italy, with information about, for example, reported income and characteristics of business. Second, they also have the universe of operational tax audits, with information about, for example, audit date and tax evasion, defined as tax assessed during an audit minus the tax paid. Now, the model learned from data on businesses to predict likely cases of tax evasion. Here's a key point. Traditional machine learning models are good at finding correlations, but we know policymaking requires causation. Now, this study went beyond the simple correlations through a more advanced auto-sample validation. By focusing on outcomes of high predicted risk cases, they ensured the model wasn't just capturing random connections. So what did they find? The machine learning approach was notably effective. By replacing only 10% of audits with low predicted evasion with high risk cases flagged by the model, they observed a 39% increase in detected tax evasion and a 29% increase in recovered funds. Now, these findings have powerful implications. By implementing a machine learning model, tax authorities could focus resources on cases more likely to yield significant returns. Now, I'd like to close today's video with variance on words. I believe these methods have a lot to offer and should be more widely known and used by economists. In fact, my standard advice to graduate students is to go to the computer science department and take a class in machine learning. Let me slightly adapt variance advice by extending it not just to graduate students, but to anyone interested in data analysis, especially to inform policy decisions. So I leave this advice to all of you, as I'm sure you are already enjoying your camping in the Random Forest.